Right, time to do a full-blown A-level question on implicit differentiation. Here's a typical standard A-level question. Find the equation of the normal, notice it doesn't say find the equation of the tangent, find the equation of the normal to the curve, there's the name of the curve, at the point 0, -4. So we've got some sort of curve, I don't know, we've got some sort of curve, and at the point 0, -4, let's say it was there, 0, -4, if you drew the tangent like so, that would have a particular gradient and a particular equation, because it's a straight line, it would have a straight line equation. But I don't want the equation of the tangent, what I want is the equation of the normal, which is that line which is perpendicular to the tangent at the point 0, -4. Now, notice the normal is still a straight line. Now, from your coordinate geometry work, you should know that to find the equation of any straight line, you only need to know two things. You need to know a point on the line. Well, I've got it. And I need to know what the gradient of the line is. And then once I know that, I can use y minus y1 equals m minus m bracket x minus x1 to find the equation of that straight line. Well, I do not know what the gradient of this straight line is, this normal straight line. So what I've got to do is a very simple process. I'm going to use implicit techniques here. I'm not told to use implicit. I've got to realise that needs to be done because I can't use explicit because there's y in two different places. I've got to use implicit techniques to find dy by dx, which is the gradient function of the tangent. So I will be able to work out what the gradient function of the tangent is. I'll then be able to work out what the gradient of the tangent is at that point. I will then be able to work out from coordinate geometry the gradient of my normal. And once I know what the gradient of the normal is, I can work out the equation of the normal. Right, so I need to find dy by dx, in other words. That's the first step. Implicit. Differentiate that with respect to x, you get 3x squared. Plus xy squared is a product of two functions. Put it in as big square bracket, I would suggest. Although you don't really need to do that this time because it's a plus in front of the bracket. But it doesn't do you any harm to just do it automatically. When you see a product, put it in a bracket. Whether it's a plus or a minus out there, it'll always come out correct. We'll do the product rule in a minute. Minus 2y, differentiate that with respect to x, you get minus 2 dy by dx. Equals, differentiate 8 with respect to x, you get 0. I've got to do the product which I'll put in the bracket. Xy squared at the side of the page. So u is the x and v is y squared. Du by dx is equal to 1 and dv by dx, well, this is function of a function. Function of x, which is the y, to a power 2. So here we go, standard result, 2y dy by dx. Power to the front, power goes down by 1, then go inside the bracket, differentiate the y, you get dy by dx. So u dv by dx plus v du by dx is the product rule. Let's sub those four things and put them in this square bracket. So u is x. dv by dx is 2y dy by dx. I'll just write it as 2y dy by dx. I'll tidy that up in a minute. Plus v, that's y squared, so plus y squared. Du by dx is 1. So we get that. So let's just rewrite this without the bracket in, expanding out by the plus, and I'll rejig that expression there. So you get 3x squared plus, I'll put the 2 first, then the x, and the y dy by dx. Plus, that is a y squared. Both of these are pluses because that's a plus there. And then minus 2 dy by dx is equal to 0. Collect the dy by dx's together on the left-hand side, and I think I'll do this in one step. I'll take out the common factor at the same time. So dy by dx is a common factor, but notice also for these two terms there's a 2, which is a common factor. So I'll take a 2 out. So 2 dy by dx is a common factor. This gives you an x and a y. That times that gives you that. Take away, take away. I just need a 1 there because that times that gives you that. So that's what we're going to have on the left-hand side, which is that term and that term with a common factor. And then the others go to the other side. So you get minus 3x squared, and take that over, you get minus y squared. Just box that off so it's not in the way. So here we go. We're going to have dy by dx then is equal to, now take out a common factor of the negative here. There's no number or no letter that needs to be taken out, just the minus, or -1 if you like, but you don't need to put the 1 in. And then inside a bracket, 3x squared plus y squared. That's what I would do. I'd take out the minus as a common factor. Is it wrong to leave it like that without taking out the common factor? No. All over, and then I'll put the 2 goes underneath, divide both sides by 2, and also divide both sides by the bracket. So the 2 and the bracket end up on the bottom line on the other side. So there you go, there's dy by dx, which is the gradient formula, the gradient function for the tangent. Okay, right, now, what I want to now work out is what the actual gradient of the tangent is. Gradient of tangent at 0, -4, which is a specific point on the curve. So what I do is I take this expression for dy by dx, and everywhere I see an x, I change it to 0, and everywhere I see a y, you change it to -4, and you work out a numerical value for the gradient. So I'm going to write m now, because it's a numerical value, equals, okay, negative, x is 0, so that's 0, plus, and then y squared is -4 squared. So you got the minus outside, don't forget, minus is still outside, that's 0, plus y squared. Well, if you square -4, you get 16, positive 16, so you get 0 plus 16 in the bracket. You've still got the minus outside, don't forget. All over, 2 lots of, inside the bracket, xy, well that's nothing times -4, that's nothing, take away 1. Let's just take away 1 then, it's easy. So this simplifies to, on the top you've got -16, and on the bottom you've got -2, when you multiply that by that. The 2 negatives cancel to give a positive, and so you get 8. So the gradient of the tangent at 0, -4 is +8. Right, from your coordinate geometry work, therefore, the gradient of the normal, because we need normal equation, remember? Gradient of the normal, if they asked you for the equation of the tangent, by the way, then we'd use this value here for the gradient of the tangent to work out the equation of the tangent. However, I need the gradient of the normal. Well, if the gradient of the tangent is +8, remember coordinate geometry, flip it upside down and change the sign. That is a perpendicular gradient. And you need to specify because +8, which is that, multiplied by -1/8, which is that, give you an answer of -1, and that's the standard test for perpendicular lines. So there you go. There's the gradient of the normal. Now we are asked for the equation of the normal to that curve at that point. So the equation of the normal comes from, therefore, at this point, 0, -4, there's the point we're going to use, with a gradient of -1/8, for that's the gradient of the normal. We use y minus y1 equals m x minus x1, which is the equation that we use from coordinate geometry to work out the equation of a straight line. Sub in. Well, it's y minus y1. y1 is the y coordinate of this point. That's -4, so you get a double negative going on. Equals m. m is the -1/8 that we've just worked out. X, take away x1, that's the 0 of the point we're given. So we've got y plus 4 on the left equals, now we've got -1/8 here, and well, because that's 0, you can just write -1/8 x. It's easy enough to just do that if you want to. I can't leave it like that, however. Whether I do it in the line above or I do it here, I've got to get rid of that 8. We don't like fractions at A level. So I'm going to times everything by 8. 8y plus 32 equals -x. And there you go. There's basically the equation of the normal. Perhaps you'd see it written down like this. You might see it as, take the -x over, you get +x plus 8y plus 32 equals 0. And there you go. There's the equation of the normal written in A-level format with no fractions. And that's the end of the question. This sort of question, by the way, would probably be worth, say, 5-6%, because it's testing not only your implicit techniques up here, but it's testing your coordinate geometry work down here together in the same question. And it's a very, very standard upper 6 A-level question and almost certain to come up on your paper.